Hi everyone, in this video we're going to be continuing with 8.4, which is on trig substitutions for integrals. And in the first video we discussed which substitutions we're going to use most commonly and when they're used. And so we're going to jump right into the next example. Example 2, we're going to integrate x squared over square root 9 minus x squared dx. And so step 1 was to determine which format and substitution we're working with. And so I have it here so you can kind of just look and know which one we're going to use. Hopefully you see it. It is going to be number 2. We're going to substitute a sine theta for x. But let's work this out with our triangle in case you don't have when to use this. You don't have this part available. If you notice, you have square root of 9 minus x squared. And so this number here, this has to represent the hypotenuse squared because of the Pythagorean theorem. It's always the side squared add to make the hypotenuse. So if you're going to have a subtraction, it's always from the hypotenuse being the larger value. So 3 squared is 9. Subtracting one of the sides squared. So that means one of these sides is x. And so then this last side is 3 squared minus x squared, square root that. So that's this side here. And so this is our angle theta. And remember, our relationship for our trig function is always that our trig function is equal to x over a. So in this case, if you think about it, x over a, in our case a is 3. Well, what is that? It's the opposite side over the hypotenuse, so it has to be sine. Okay? So that's just guiding you to it in case you didn't see this, if you didn't have this available to you. But if you had it available, you could just jump right to it and you can say, well, x, if you recognize that this is 3, x is 3 sine theta. Okay, so that's step 1. Step 2 is going to be to find dx from your x over here. So dx is just this derivative with respect to theta. So it's 3 derivative cosine, sine is cosine, cosine theta d theta. All right, and then we are going to substitute these in step 3. So step 3, substitute these into your integral here. And now this is different than our first example because we have an x squared on top. So let's start with the square root on bottom. This is 9 minus x is 3 sine theta, and then it's getting squared inside the square root. Okay, so 9 minus that in the square root. In the back, or you can put it on top if you want, dx is 3 cosine theta d theta. So this is different than example 1 because there's an extra x squared up here. But it doesn't change anything as far as what you're going to do. You're still just going to substitute. So x is still 3 sine theta, and you just are squaring that. So we square that there. And then step 3 is substitute and simplify. So let's start simplifying this. I'm going to work with the square root again and break that down first. So this is 9 minus, if you square this, you get 9 sine squared theta. And then you're going to factor out, so just working with the square root here, we're not working with the whole integral. Factor out a 9. This is 1 minus sine squared theta. And from your trig identities, we know this one. This is cosine squared theta. And so we get that this is square root 9 minus cosine squared theta. And then, oh sorry, not minus, 9 times cosine squared theta, and then square root this. This is just 3 cosine theta. And so that's the denominator. Okay, so let's keep going. Let's make this look better now, the whole thing. So this is the integral of, let's square the top. This is 9 sine squared theta times the 3 cosine theta from the back. The d theta is all the way back there. Over the whole denominator just became 3 cosine theta. And so keep simplifying. This 3 cosine theta divides out with this one on bottom, and we end up with, I'm going to factor out that 9 to the front, 9 sine squared theta d theta. And so this is a whole lot easier to solve now. However, we do need to use another trig identity to substitute here. So this is not necessarily a trig sub. Trig sub refers to subbing in for your variable x, one of the trig functions. At this point, we're just doing a trig identity. So we're relying on the identities that we know from the past. So recall that sine squared x, or sine squared theta, can be rewritten as 1 minus cosine 2 theta over 2. So we've seen this identity come up a few times in past examples, but one of the reasons why we want to rewrite sine squared like this, even though we know we can rewrite sine squared different ways, but we want to choose this one because we no longer have a trig function squared, and we can just use u substitution when we pick this. Alright, so let's factor out this 2. So I'm going to make this 9/2 in the front, and this is 1 minus cosine 2 theta d theta, and we can integrate this one really well pretty quickly. So using u substitution on the second part of this, let's just integrate the first term. This is just theta. Okay, so let me break this into two parts. Minus 9/2 integral cosine 2 theta d theta. Alright, let me move this up so we have some more room. Okay, so I just moved up what we were working on down in this corner, and I also kept what we had here as far as what we substituted for x. So we had integrated 1, we got theta. Now, just real quick, u substitution, u is 2 theta, du is 2d theta, and so we'll substitute 1/2 du for d theta. Okay, so we get negative 9/2, and you can factor out this other 1/2. 1/2 times 1/2 is cosine u du. So this is negative 9/4. Integral of cosine is sine u, but u was 2 theta. Okay, let's make that look a little better. 2 theta. And then we had a 9/2 theta out front. Okay, so this would be the answer if things were in terms of x. So this is where we do step 4 again, where we have to resubstitute in our function so that we have x again, because we had x originally. Now, on the first example, example 1 in the previous video, we used our triangle instead of using inverse functions, but in this one we actually have to use sine inverse, and here's why. We have an individual theta right here, and so we can't use our triangle because our triangle is ratios of the sides, and that's our trig functions. So right here we have to use sine inverse. So from what we know about sine theta is x over 3. Well, that means sine inverse of x over 3 is theta. So we're going to substitute that in right there. So we have 9/2 times sine inverse x over 3 for our first term. And then over here, 2 theta, well, that one's a little tricky because we only have information about single theta. We don't know about twice theta, that angle measure. And so what you have to do here is you have to use another trig identity that's allowing you to rewrite twice theta in terms of just single theta. And so the best choice here, let me write that for you, sine 2 theta equals 2 sine theta cosine theta. So why this is a good choice, again, is because it allows us to rewrite a trig function with twice our angle in terms of trig functions with just our regular angle, because we have a triangle we can refer to with the regular angle theta. So back over here on the side, I'm just going to identify what sine and cosine of theta are so I can plug them into this formula. So we have that, we know what sine is. Sine is x over 3, sine of theta. So let's just do cosine. So cosine theta from this triangle is adjacent over hypotenuse. So square root 9 minus x squared over 3. And so we have in our answer minus, so we're on this part, minus 9/4. It was sine twice theta, so that became 2 sine theta cosine theta. But that part became, we're going to say 2 times, we know what sine of theta is, it's x over 3. So 2 times x over 3. Cosine theta is square root 9 minus x squared over 3. And let's make this all look a little bit better for our final answer. 9/2 sine inverse of x over 3. This 2 is going to divide with this 4, so that's minus 9/2 x over 3. Actually, the 3's can divide it as well. Let me do this all at once. So this 2 divides with this 4, leaving a 2 on bottom. And this 9 on top divides with these 3's on bottom, leaving a 1 on top. So then we have just a 1/2 times x times square root 9 minus x squared plus c. All right, and that is the answer.